Okay. Okay, so I kind of feel like Martha Stewart. I already have this prepared. So y'all took the poll. So let's see. So what's the distance between the points A, B, and C, D? And almost everybody got it correct. So the answer is C. Oh, hello. There we go. So the answer is C. And how do you see that? Um, so how I always remembered it is you want to take the difference um between the two x values and then the difference between the two y values. Okay? So because these are our x values, they're going to be put together here. Okay? And then my two y values, they're going to be put together here. Right? Because I want to compare apples with apples and oranges with oranges. Right? That's kind of how one way to remember it. But unfortunately, it's just one of those things that's going to be helpful to memorize. You can always do a sanity check with 2 points that you know the distance. So, like, you could do a sanity check with like 0, 1 and 0, 2, right? We know that's a distance of 1, okay? Because we haven't moved like left or right at all. We've just moved up 1, okay? So, so you could always do a sanity check with yourself like that and make sure that you're getting that answer. Um, okay. Any questions on that? And I do have my volume up. Yes, I do. Okay. Oh, let me put the chat on my second screen. Okay. Wow, okay. All right. I don't know what's going on there. Okay. Anyway, what is the formula for a circle with center AB and radius R? Again, most people got this right, but the people who got it wrong were really, really close. Okay, so the answer is C. Wait a minute. Oh my God, they're different. Ah, sorry. This is B. Yeah, sorry, my bad. Okay, the answer is C here. Okay. So once again, we want to compare apples with apples and oranges with oranges, right? So I'm putting, so, but, wait, wait, is this really different from, no, it's not. Okay. So I'm putting X with A because A is in the X part of my point, right? Because remember, we put points. I mean, I think you all do remember it because you all answered this part correctly. I feel like this is too thin. Um, this is like X comma Y, right? So I want to put my X's with my X's and my Y's with my Y's, right? And then this is just one of those things you just try to remember that it's R squared, okay? Um, but if you got A, definitely don't beat yourself up about it. At least you got it mostly right, right? You just didn't remember that it was R squared instead of just R. Um, One way that I would often remember that is that oftentimes our answer, because of the distance formulas, oftentimes our answer for the radius is a square root. And so it's nice when we get to square them. But okay. What is the formula of the circle with center that thing and radius R? Wait, and a point 1, 1. So what do I mean by that? I mean that the center of the circle is at 3, -1, right? So I don't know if I'm mirrored or not to you all. I guess maybe let me not try to do it with my hands. Um, and then there's a point on the circle. 1, 1 is one of the points on the circle. Okay. So almost everybody got it right, but honestly, probably if you got B wrong, right, then you probably use that formula for number 3, right? And so can't blame you for that at all, obviously. That makes sense. So there's 2 ways that somebody can go about this. I'm going to go over this, even though most people got it right. Um, so the 2 ways are, one is you can do, so 2 ways. I mean, there's probably more than 2 ways, but these are the 2 ways I'm going to show you. 2 ways. Okay. So first way that you could do it is you could say, I'm going to find R using the distance formula. Because fun fact about circles are they have a center, right? And then every single part, yeah, every single point on that circle is equal distance, right? From that center. Okay. So no matter which point you choose on the circle, it's always going to be the same length away from the center as all the other points. Okay. Because circles are perfectly round, perfectly round. Okay. So you give me 1 point on it and the center, and I could find the radius. You give me another point and the center, I could find the radius. Okay. Any point on the circle and the center. And the center is not part of the circle, right? But it's like an important part of understanding the circle. Okay. So, okay, so I want to find the distance between the center, right? Negative, oh, sorry, +3, my bad. -1 and the point on the circle. Okay, am I recording? I am, okay. That has happened before. Okay, so what am I going to do? I'm going to use my distance formula, right? So I need to compare apples with apples. So I got 3 minus 1 squared plus -1 minus 1 squared. And so it doesn't matter who I do first, okay? So I could also have done 1 minus 3, right? This is the same as 1 minus 3 squared plus 1 plus 1, because 1 minus -1 is going to be 1 plus 1 squared. You can even switch them up, okay? You can do 3 minus 1 squared plus 1 plus 1 squared, because you're going to get the same answer because we're squaring it, okay? So who we're minusing from who doesn't change like the absolute value of that number. It just changes whether that number is going to be like a positive number, a negative number, like, so like on the left-hand side here, how do I make this? Here we go. So this one is going to be -2, but when we square it, -2 squared is going to be 4. This one's going to be 1, sorry, 2. When you square that, that's going to be +4, right? When you square something, you always get either 0 or positive. Okay, it's just like absolute values, right? So it doesn't matter. You can mix and match. That's fine. Okay. There'll be things later on in our lives that you can't mix and match, but with the when you were squaring and stuff, you can. It's fine. Okay. Because I know some students get nervous about that. They're like, oh, I gotta make sure. With the distance formula, you don't have to stress about that. Just make sure your x's are with your x's and your y's are with your y's. Okay. Okay. So what do we get? So we get 3 minus 1, that ought to be 2. 2 squared, that's 4. So I get 4 plus 4. Right? So that's going to be square root of 8. So that's our radius. Okay, that's our r. And then I could just do the formula, right? So our formula is we do x minus the x value of our center. So that's going to be x minus 3 squared plus y minus -1. Okay, that's how we got that +1. But it seems like y'all caught that, so that's good. So y plus 1 all squared equals r squared, right? But square root of 8 squared is 8. Boom, roasted. Okay. Oh, oh no, that's the next one. Okay, cool. Any questions? Where's my chat bubble? Where did it go? Oh, okay. Great. I feel like one of those Twitch streamers or like those Instagram live people talking to chat or something. Okay. But I promised you 2 ways, right? So this is the answer, I guess. But I think we already said that. Oh, I guess I didn't write it down. All right, what's the other way? So the other way is you can plug in the stuff that you have in your formula. But then I don't have the radius. So what do I plug in? Well, let me see. Let me write that down. Plug in. Oh, I keep trying to make it -3. I don't know why. But I'm just plugging it into the circle formula. Okay. So what does that mean? Well, I have so far, right? I know I have this. We're pretending like I didn't just solve for the radius, right? Because this is the scenario where I remember what the circle formula is, but I don't remember what the distance formula is. Or this could be your sanity check, right? Sometimes on exams, well, this is really only if you have extra time, I guess. But sometimes when I was on exams, I'd be like, I just got a weird number. I don't know if I did that right. Let me try to solve it a different way and see if I get the same answer. If I get the same answer, then either I hit like bad luck gold or I'm right, you know. Okay, only if you have extra time now. Well, what does this X and Y stand for? It stands for points on the circle, right? This is like what we're setting up for this solution that we just came up for gives us the parameters that X and Y can be on our circle. Okay, so with this part here, what we can do is we can just plug in a point on our circle, right? Because that's what X and Y stand for. They stand for the points that are on our circle. Okay. So is it really 1, 1? Yeah, okay. I was like, did I just make the one of them positive without meaning to? Okay. So I'm going to plug in 1, 1. And now this is not my formula for my circle, like in general, in full generality. This is just me trying to solve for R. Okay. I just want to figure out who R is. Excuse me. So 1 minus 3. And if you notice, this looks an awful lot like the distance formula, doesn't it? Not an accident, right? This is math is fancy like that. Well, or maybe not fancy. I don't know. I don't know what words you would use for that. Special. Okay, negative 2 squared, that's 4. Plus 1 squared, that's 4. So I'm going to have 8, but I'm going to square root both sides, right? But remember, every time I square root both sides, I got to do the plus or minus stuff. Okay? So plus or minus square root of 8, those are. Okay? But here, radius is our distance. Like, if you look it up, some people do talk about, radius being negative, and it's not a terrible thing. It's just, I don't know. For me, I prefer to just take it as the positive one, right? That's when I'm facing this way, I go in a positive direction, right? Instead of going backwards. So it's kind of like a weird thing. If you go into like Calc 3 and stuff, there will be times that you do want stuff to be negative, but I don't know. I don't want us to stress about that. Oftentimes in this class, especially in 224, will be put with things like this, and it's like the negative one just doesn't make sense. So you pick the positive one. Okay, so we pick the positive one because that's one that, at least for me, makes more sense. So r equals positive square root of 8. Okay? But remember, I'm not done. The question, so whenever this is advice I'm going to be pounding on the table, reminding you all about, but also reminding myself, because whenever I screw up things, it's usually because of this. Whenever you think you're done, reread the question. When you think you're done, when you're stuck, when you're confused, reread the question. Okay? I get it. I get it. A lot of people don't like to read the question because they're like, why am I wasting my time rereading the question? It is not a waste of time. We often miss things. We often read fast, or we're nervous, or we forget what we're trying to solve for. Like, how many times have I gotten on track with something? I'm like, oh yeah, I know I'm supposed to do this thing. And then I circle it and then I move on. But that's just part one of the question. That's just part one to finding the answer, right? So I'd be tempted to circle this, right, and just move on with my day. But if I reread the question, what is the formula for the circle? Not radius. Radius is part of what I need to know the formula for the circle, but that's not what I'm circling and moving on with my day. Okay? Okay. So, and I'm going to keep reminding y'all about that because uh, it really is so helpful. Or when you're stuck, so many times when a student comes into office hours or like raises their hand during the exam or quiz or something, and they're like, I'm stuck, I don't know what to do. Our first step is to reread the question together. And so many times the light bulb goes off for the student, right? Just from rereading the question. So I'm not just pounding my fist just to pound my fist. I'm really, this is like a tried and true thing. Okay, back to business. Here's our formula for circle, and it's r squared, so we're going to get 8. Now I circle my answer. Okay, any questions? Fabulous. Um, okay, yeah, there's something that I want to talk about with square roots. So this is part of the algebra review that I had wanted us to talk about before, but we just didn't have time. This is another one of those things that, like, if I wasn't afraid to fall, I would stand on top of a chair. I could put my standing desk down and pretend like I'm standing on top of a chair. Um, but and I would like shout from the rooftops, exponents cannot distribute over addition or subtraction. Okay. They do distribute over multiplication and division, but not addition or subtraction. Okay. So let's look at part of what we did above. Okay. So square root of 4 plus 4. I'm not distributing that over addition, right? I'm doing square root of 8. Okay. Oftentimes students like to simplify stuff more, and that's fine. I'm happy with you to leave it as square root of 8. I'm happy with that. We can simplify this, okay? And how you do that is you think about what are the different ways you can multiply to 8. 1 times 8, but that's not helpful, right? 4 times 2. 4 is a square, okay? So I got 2 times 4. So, okay, sorry, let me rewind a little bit. I was talking about exponents and now I'm talking about square roots. Remember that square root of something means that thing inside raised to the 1/2. Okay. And then like cubed root is the 1/3. Fourth root is 1/4, et cetera, right? So the nth root for n some positive number, 2 or bigger, um, we get that. Okay. 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 So exponents distribute over multiplication, meaning you can split it over multiplication and division. Okay. But not addition or subtraction. So we're going to show that in a second. But let's look at this. So I get square root of 2 times square root of 4. Totally legal for me to do. That is correct to do. Okay. And square root of 4, I know what that is. That's 2. Okay. Square root of 2, I don't know what that is. It's actually an irrational number. It never ends. Like pi, for example, right? So square root of 8 is equal to 2 square root of 2. Okay. You do not have to do these kinds of simplifications always, but it's something I wanted to cover quickly. And here's another thing that I want to cover. This is wrong. This is wrong, what I'm about to write. Okay. But people do it a lot, and it always makes me sad because it's a reasonable mistake to make. So I'm going to keep reminding you that this is not true, that this is false. Okay. So if I start with the same problem, I do 4 plus 4, right, under my square root. If I try to distribute the square root over addition, meaning split it over addition, which is not correct, this is wrong to do. Okay. This is mathematically wrong to do. That's wrong. But now I know what the square root of 4 is, right? So I get 2 plus 2. These two things are not equal to each other. 2 times square root of 2, that never ends. That never ends. It's like what is it? I think it might be 2 point blah 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 blah. Right? But the after the dot, it like never ends, right? Before is a whole number, it's just 4, right? 4 is strictly greater than 2 times square root of 2. Okay. Another way to think about it, square root of 2 is less than 2. Okay. So we have 2 times something less than 2, that's going to be less than 4. Now I feel like I'm making it even more confusing. But so what's the upshot of all this? Cannot split or distribute or however you want to think about it. Any exponent over addition or subtraction. but you can over multiplication and division. That's fine. All right. I'm going to start assuming that y'all will message me when you have a question instead of keeping asking if people have questions. Which feels weird, but oh, well, maybe people will want to unmute. I guess I don't know. Okay. All right. So, parabolas. Okay. There are so many other shapes, right? So many other shapes. If you go on with your calc journey, you'll learn about so many, so many other shapes. Okay. The next one I want to talk about are parabolas. So these are cool. Probably the main example that people know about is y equals x squared. So let's start with that one, right? So example, so when you're trying to draw something, right? And probably a lot of you already know how to draw this. And just remember sort of my teaching, part of my teaching philosophy is I like to do things with an example that maybe you already know about. And then once you try to implement that strategy with something harder that you don't know about, hopefully it'll be a bit easier to do. Um, or you will feel like you've already done, you already sort of understand the process. Oh, hello. See, this is what I like doing with my iPad because then I can try to make them straight. Okay. And then I proceed to not make it straight. But you can always plug in numbers, right? And just see what happens. So if I plug in 0 in for x, well, 0 squared is 0, famously. I can't look at this. I can't look at this. Oh my God. Okay. All right, here we go. There we go. Okay. 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 1 squared is 1. Right? Okay. -1 is squared is 1. 2 squared is 4. -2 squared is also 4. So hopefully you sort of see a pattern, right? And I'm not saying that you can draw everything based off of just a couple of points because oftentimes things will get kind of crazy, right? Or like something weird happens at not a whole number, right? Because that's usually where we plug in, right? Our whole numbers, because they're easier. All right, well, let's try 1/2. 1/2 squared is gonna be 1/4. Interesting. So when it's less than 1, we actually get a small, when x is less than 1, y is a smaller number than x. And then -1/2 is also going to be 1/4. But when x is bigger than 1, our y is actually bigger than x. Oh, okay, cool. Oh, sorry. When I said less than 1, I meant less than 1, but greater than 0. Should be more precise. Okay. So one thing that you can do, because oftentimes we will ask you to draw things. Okay. One thing you can do, I mean, this drawing, hopefully y'all can just memorize because this is a very useful drawing to have memorized. Okay. Um, but if you don't, right, if you don't have the drawing of whatever we're asking you for memorized, at least plot some points. Okay. Maybe you don't remember all the tips and tricks that I'll give you over the next couple of classes, but at least plot some points. Oftentimes I can give y'all points just for plotting some points. Okay? Just for being like, okay, I know that 0, 0 is the point on this thing. I know that 1, 1 is a point on this thing, etc., etc. Okay. Okay, so some of the points that we got here were 0, 0. We also got 1/2, 1/4. Okay. And negative 1/2, 1/4. Okay. We got 1, 1. Negative 1, 1. Okay. 2, we got 1, 2, 3, 4. And you don't always have to draw stuff to scale. I'm just trying to do it at least a bit to scale. All right, here we go. Here we go. And y'all can see with your own eyes that I'm not very good at drawing. But what I don't want to see is I don't want to see straight lines where there's not straight lines, right? I've got a bit of a curve here, right? We've got a bit of a curve happening. Okay. Similarly here, right? If you draw straight lines connecting these points, I have to take off points. Okay, because I've seen questions similar to this on exams and stuff, and I have to take off points. Okay. Because this is a coordinated class and stuff. And also, honestly, even if it wasn't coordinated, I still take off points because it's not straight lines, right? As long as they look a bit curved, right? So long and short of it is, what does a parabola look like? Actually, let me draw the parabola and then I'll draw the XY. Oh my God. Oh my God. See, this is why I like the tablet, because then I can keep erasing stuff. There we go. Right. That's a sketch of what it looks like. Right. That's a quick sketch. And as long as at least have that, right? And then this is just a more precise sketch on the left. Okay. So, but there's a bunch of other parabolas, right? You could have y equals negative x squared, where the negative's on the outside of the x squared, right? So negative parentheses x squared. That's just the same thing, but upside down. Okay. And you can have it shifted to the right, to the left, squished down, pulled out, all kinds of different stuff can happen, right? The general formula for a parabola is y equals ax squared plus bx plus c. My rabbits are trying to get out of their room, scratching on stuff. But a is not allowed to be 0. If a is 0, that's just a line. That's not a parabola, right? This x squared part is really important. The a can be negative, it could be a fraction, it can be 100 million, but it can't be 0. Okay. All right, let's take a break. Let's take a 5-minute break, and then when we come back, I'll show you some more examples. All right. Welcome back. Okay, so one thing, so now I'm going to cover a couple of things, a couple of quick facts to know about. No, I say a couple, but no, it's quite a few, isn't it? Okay. So first is if A is greater than 0, right? Then we have something that looks more like that, right? Where the cup is going up, right? It might be small, wide, it could be shifted up, down, whatever, but the cup is going up, right? Like if it was raining, it would be collecting water, okay? If A is negative, okay, because remember, A can't be 0. If it's a parabola, if it's, I mean, then it's just a line, okay? Then we have something that looks more like this, right? So it's like Oh God. It's like facing down, right? It could be shifted over, up, down, squished, wide, whatever, but it's upside down. Okay. If it was raining, water would be like pouring off of it. Okay. C is the y-intercept. So remember, y-intercept means where does your curve intercept the y-axis or intersect with the y-axis? Okay. And the y-axis, right? Y is a whole bunch of different things on the y-axis, but x is always 0 on the y-axis, right? Like if you think about it, right? And if you're anywhere on the y-axis, x is 0. Okay, so this is when x equals 0. And then similarly, the x-axis, the x-intercept is when y equals 0. Okay. So the y-intercept for parabolas is often a lot easier to find because you just plug in 0. Okay. So you plug in 0 and you just get C, right? Like look at our general formula. If I plug in 0 for x, those first two terms go away and I just get y equals C. Okay. So that's how I know my y-intercept is C. Okay. So like for our example up here, C was 0, right? Because A was 1. So we have a curve up. B was 0 and C was 0 because we don't have any other terms. Okay. So our y-intercept is 0. So when x equals 0, y equals 0. So our point is 0, 0. Okay. Um, so oftentimes we want to find the y-intercept, right? The x-intercepts are also nice. So why is it that we usually find these intercepts? Well, they're usually important points, but also it's nice when you get to plug in 0 into something, right? Like these are kind of like nice things like, okay, I'm going to plug in 0 for y, I'm going to plug in 0 for x. And oftentimes that's what we're looking for, right? We're looking for the x-intercepts. Okay. Now I'm just rambling. Sorry. Um, when you factor, you can find the x-intercepts or intercepts, right? So it could be either one, and then this is when y equals 0. Yeah. If there is one, sorry. Yep, if there is one. It could be that there isn't. Okay. So take our example above and just shift it up 1. Take the whole drawing, shift it up 1. Now you never touch the x-intercept, right? Right now our x-intercept is also at x equals is at y equals 0. It's the 0, 0. Okay. But if I shift it up 1, I would never touch the x-axis, right? So sometimes we don't even touch the x-axis. There's not even an x-intercept. Okay. So how do you go about it? You set y equal to 0, right? So you get 0 equals, and then you factor the right-hand side. So x minus k, x minus L, right? And so I don't know where we are on the y-axis. So I'm just going to draw the x-axis here. Okay. So let's just say that k is less than L, right? I don't know. I don't actually know what's going on here, but like without loss of generality, we can assume that k is strictly less than L. Because when you're actually doing the work, you'll actually know what's what, right? Like k will be -2 and L will be 3 or something. I don't know. Okay. So Oh, hello. So it could be that we look like this, or we could look like this, right? So this is K, this is L, this is K, this is L. Okay. But we could also have that K equals L, right? That's like our first one. Our first one is when you try to factor that, you just get 0, right? X minus 0 times X minus 0, because it's just X squared. Okay. And this is a lot harder than it needs to be, right? I'm just trying to draw some examples. This is not like stuff that you need to memorize. Really the main things that you need to memorize are the general formula, and y-intercept is when x equals 0, x-intercept is when y equals 0. And you need to factor and do all this other stuff. Okay. So what are the two things that we could look like? Well, we could look like this, or we could look like this. So when they're the same, when k equals L, that means that we're only touching the x-axis at one spot, right? Just like when we had x squared, we only touch the x-axis at one spot. When k and L are different, we have to touch it at two different spots, right? Because we have two different x-intercepts. Right, so let me show you an example when there is none. So if I have y equals x squared plus 1, and you'll learn later about like this different shifting and stuff. So that just means that I'm shifting the y equals x squared up 1. Okay. So what does that look like? That looks like this, where it just looks like y equals x squared just shifted up 1. Right? How many times have I said that? Right? So many times, but I guess here we are. So this one we know how to draw, right? Or at least I'm telling you how to draw it. You're not always going to know how to draw these things, right? Sometimes they're going to be really crazy and like, maybe not super nice. So I'm going to show you on one that we know how to draw. We can literally see that there's no x-intercept, right? And we're going to talk about it. So x-intercept. So we set y equal to 0. And now I want to factor this. There's no way to factor that. Not in real numbers, at least, which is all that we need to care about for this class. Because let's see. So if I'm trying to do, you can try to do quadratic equation. You could try to do a whole lot of stuff, but quadratic equation, you're going to end up getting a negative underneath the square root. And that for this class says, that means that there's not a solution. Okay. That doesn't mean you did something wrong. It just means there's not a solution. Okay. So no solution to this. Womp womp. But if we look over to the left, we see that that makes sense, right? Because we know how to draw it. But like I said, oftentimes we don't know how to draw things, and so we're trying to find the x-intercepts, the y-intercepts, in order to be able to draw it, right? But this is saying that we have no solution here. There's no x-intercept. Okay. And sometimes this happens, right? Well, obviously, because I just showed you one, but uh sometimes no x-intercept the quadratic equation or quadratic formula, I can't remember which one it is. Anyway, has a negative under the square root, which is bad, right? Negative under the square root is bad, not a real number. Okay. We don't have to stress about what it is, okay, for this class, but it's just all we know is it's not a real number, and that's all we need to know for right now. Okay. Any questions? All right. So there are also parabolas that are kind of turned on their side. Okay. These ones I'm not going to focus on very much. Uh, so it's like you swap the x and the y. So x equals y squared. And so if we keep our axes the same, where the up and down one is the y and the side to side one is x, now it looks like it's on its side. Oh God. Okay. I'll pretend I actually hit that point. Jesus. Um, and there's other things, right? There's stuff that I didn't cover, like the squishing and the pulling and the shortening and the lengthening and all kinds of stuff. Okay, but you can watch the videos um and stuff, but these are the main things. Oh, there's also another important one. I always forget what it's called. The vertex formula, I think. Excuse me. Okay. So yeah, I should have said that up here. Let's mhm. Okay, vertex formula. Okay. So the vertex is like that point it's like between. Oh, that what does that even mean? Um, like either your bottommost point or your topmost point, right? If it's a upward thing like this, it's your bottommost point. If it's a downward thing, I can never make that look normal. It's the topmost point. Okay, it's a vertex. It's like where your thing sort of starts to turn around, or it does turn around at that point. Okay. So this is an important one to memorize as well. Unfortunately, I don't have a trick as to how to memorize this, so that's my bad. But so if I call my parabola f of x, okay, and I say ax squared plus bx plus c, the vertex, the x value is negative b over 2a. And then the y value, just plug that x into it, okay? I just plug that back into my function. There is a formula for it, but like, I don't want to memorize another thing. So for me, that this is all I would do is I would just try to memorize the x value and for the vertex, and then you can just take that and plug it into your um formula to find what the y value is. Because the f of x, that's just the y value. Okay. Um, so if b is 0, then your x value is 0. All right, any questions? I don't know why my chat bubble keeps disappearing. Okay. Yeah. Okay, another important one. Hopefully we get to, oh, we're not gonna get to everything. Okay, that's fine. Hyperbolas. Okay, so hyperbolas, the one that most people know about, or probably is more common, is 1 over x, right? But how we're gonna write it is we're gonna write it as x times y equals 1. Okay. So this is another nice one to memorize. Okay. So what are some things that are true or that are not possible here? Well, x times y needs to equal 1, right? So if x was 0, I can't make y anything to make 0 times y equal 1, right? Because if x is -1, I just make y -1. If x is 1/2, I just make y 2, right? If x is -11,000, I just make y 1 over -11,000, right? So the only things that really make this break are if either of them are 0. Okay, so neither of them can be 0. That's not inside of our realm of possibility. If one of them is 0, then I get 0 equals 1, which is false, right? So we often see this as y equals 1 over x. Okay, and so that's another way to see that x is not allowed to be 0, right? Because you can't divide by 0, that's illegal. But also, if we have something 1 over x, there's no way to make that 0. You can't make 1 over x equal 0. There's just not a way to do it. All right. But what happens, right? So if x is really close to 0, what happens? Right? I guess I gave it away with my drawing. But if x is like 1 over 100,000, because that's really tiny, right? How I always try to help people imagine this is, say the numerator, the top part, is how many slices of pizza you get, and the denominator, the bottom part, is how many slices the pizza is cut into. Okay, so if I have a pizza, it's 1/2. Okay, so you get 1 slice out of the 2. Well, you've got lunch today and lunch tomorrow, right? 1/4, you got lunch today. If I cut this into 100,000 pieces, now you're hoping that you're on Ozempic because pretty much all you get to do is smell the pizza, right? And I haven't even cut it into 100,000 pieces yet. You get 1 slice out of 100,000 out of this one pizza. You get to look at the pizza, right? So as your denominator blows up, your whole number goes to 0. Okay, so as your denominator blows up, your whole number goes to 0. Okay. But what happens when I plug that into my y equals 1 over x? Well, I get y equals 1 over 100,000. But remember, when I divide by a fraction, I multiply by the reciprocal, which is a fancy way of saying I flip the bottom. So I get 1 times 100,000 divided by 1. But times 1 divided by 1, that just makes the number the same. So I get 100,000. Huh, okay. So if I were to add more zeros onto my denominator, right, I make this 1 over 1 million, right? This just keeps getting bigger and bigger, right? So as x gets closer and closer to 0, y becomes humongous, right? At least from the positive direction. But from the negative direction, if I just slap a negative onto this, as x gets closer and closer and closer to zero from the negative direction, y blows up, but just in a negative way, right? But you can see that here, right? As x gets closer and closer to zero, from this, again, sorry, I don't know if I'm mirrored or not, but as x gets closer and closer to zero from the negative direction, y is blowing up in the negative direction, shooting down to negative infinity. As x gets closer and closer to zero from the positive direction, y shoots up to positive infinity. Okay? But as x blows up, as x gets closer and closer to infinity, y is getting smaller, 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 right? Because my denominator is blowing up, so my whole thing's going to zero. So as x gets closer to zero, y blows up, either in the positive or the negative direction, depending on if x is positive or negative, right? But we never actually touch zero, right? X never actually touches zero because x being zero is illegal, right? So we get really, really, really close. Remember, this is that Jujutsu Kaisen and infinity thing. I should have looked up how to do the thing, or that's your sibling being like, I'm not touching you. You're getting infinitesimally close to x being zero, but you never actually touch zero, right? You get 1/100 bagillion, bajillion, million, zillion, gillion, right? Whatever, like the biggest number you could think of. And you could still go a little bit further, a little bit further, a little bit further, right? You get all the way there, but you can never actually touch zero. Okay. Okay. But what happens as x blows up or in the positive or negative direction? That means y gets closer, closer to zero. All right, so as x blows up, y goes to zero. But again, never actually touches zero. Okay, so here we actually have two what they're called. Oh shoot, what are they called? Oh my gosh, of course I have a brain fart now. Oh my God, it'll come to me. Um, you have two lines that you never actually touch. Oh my God, now I need to just Google it. Uh, line you never touch. Asymptote. Oh yeah. So we have two asymptotes. X equals zero, which is the line where x always equals zero, right? Which is the y-axis, because we can never actually touch it, but we get really, really close to it, right? And from both sides. And then we also have the asymptote y equals zero, right? Where we get really, really close to y equaling zero, right? As x gets closer and closer to infinity, y gets really close to zero. And as x gets closer and closer to negative infinity, we get closer and closer to y equals zero. Um, sorry, it looks like I'm making it look like the right thing, but I'm not sure if I'm mirrored or not. I don't know. Anyway, so we have those two asymptotes. Oh, I can't believe I forgot what that was called. Okay. Well, hyperbolas always have two asymptotes. Okay. So here are two other examples. So, oh geez. So the dotted lines are the asymptotes. Okay. But it's interesting because I can draw the same two asymptotes, but there's two different hyperbolas that can go with this. The first one is I can have them approaching. Oop, okay, I didn't draw that very well. Sorry. So remember, these purple lines are approaching, but never actually touching these asymptotes. I can have something that looks like this. Yay, come on. Okay. Or I could have something that looks more like this. Oh my God. Just pretend I'm good at drawing. Ay, confused. Okay. So what are these? This first one is x squared over a squared minus y squared over b squared equals 1. And the second one is y squared over a squared minus x squared over b squared equals 1. Okay. Okay. For this first one, without looking at the drawing, by just looking at the formula, we can tell that x can't be 0. Okay. Why is that? Well, remember that because we're squaring x or squaring y, we can never have a negative number, right? We can have 0, we can have positive numbers, but we can't have a negative number. Okay. So if x was 0, right? If this part went away, so let me write it a different way. Let me write it how I plan to write it. So trying to do something different. So if x can't be 0, because if x was equal to 0, we would have negative y squared over b squared equals positive 1. But y squared and b squared, they're either 0 or positive, right? But then we're negating, right? We're negating. So if it's 0, then 0 equals 1, illegal. Do not pass go, do not collect 200, right? But if we're positive, we're negating a positive thing. And so now we have a negative thing. A negative thing can't equal positive 1. Okay. So x is not allowed to be 0, but y could be 0, right? If y is 0, that's fine, right? X just has to be whatever, x squared just has to be whatever is going to make, x squared just has to be a squared, right? And we could see that in the drawing here. Oh, hello. Right? We could see that we never touch the y-axis, which is when x equals 0, but we do touch the x-axis, which is when y equals 0. Okay. Similarly, for our other one, y is not allowed to be 0. Because then negative x squared over b squared would have to equal 1, which is impossible. Any questions? There's lots of other hyperbola stuff. There's a ton of things. You can figure out what these asymptote lines are from A and B, but it's a lot. And for me, I'm trying to let y'all not have to memorize too much stuff. But I at least want y'all to be able to recognize when you're looking at a thing, oh, that's a hyperbola. Okay. If it has asymptotes like this and stuff. Yeah. And definitely want you to be able to draw y equals 1 over x, right? Oftentimes we write as y equals 1 over x. Sometimes we write as x times y equals 1. Definitely want you to memorize that one. That's going to be an important example, counterexample throughout the rest of your calculus career, including this class. Okay. All right. And I see the time. I know we don't have much time left, but I'm going to quickly tell you about ellipses or ovals. Right. So the total ellipse of the heart. Okay. So these are ovals, right? I'm going to try my best to draw this. We're going to see what happens. Oh my God, I can't. I'm already. Okay. Okay, let's see. Oh my God. Oh my God. Oh, so close. No. Oh my God. Come on, come on, come on, come on, come on. Oh, okay. All right. All right. We're just doing it. Okay. Oh my God. Oh my God. Okay. Pretend that looks nice. Okay. Make believe. Okay. So, okay. The formula for the center being at 0, 0. I do not expect y'all to memorize this. Um, well, maybe you could memorize. I don't know. If you can memorize this, that's probably going to be helpful, maybe, but so it looks a lot like hyperbola, right? But now it's just plus. Okay, well, some of the hyperbola um formulas. Okay. So, um the when the center's not at 0, 0, it's a bit more complicated. Like it's gonna be like x minus something all squared over a, like over a squared and all this stuff. Um, but yeah, so ellipses are when a and b are not equal to each other. Because if a and b are equal to each other, this is just a circle. Mama, that's a circle. Okay. So another way you can think about it, because oftentimes when you're solving stuff, this is how it pops out, is it ends up looking like this. Okay. But these are the same, right? They're equal. It's just I just wrote the fraction as a fraction times something. Okay. And x and y are both allowed to be 0 here. Okay. So when x equals 0, then we have y squared over b squared equals 1. So it's just y squared equals b squared. Oops. Right? So that's why on the y-axis, when x equals 0, we have negative b and positive b, right? Because I square root both sides, but I got to do that plus or minus stuff, right? So I would get y equals plus or minus b. Similarly, when y equals 0, oh, sorry, over a squared, my bad. Okay. Okay. So we've got some stuff that I want to go over next time, but really quickly, and since it's recorded, I don't feel too bad doing this. Um, because this is not good pedagogy, but at least if you look at this later, you could pause it and stuff. And I'll go over it next class. Don't worry about it. But so these are some quick tells. Okay. So this is once you've factored out the whole thing and everything, um, if there is something on the left, the something on the left, then it's a whatever it is on the right. This does not go the other way. Okay, because hyperbolas can look a lot of different ways, right? Like x times y equals 1. Remember that was a hyperbola, right? So it's not that, oh, from the right to the left. You can always do that. But if you have something that looks like on the left, it's something that's on the right. Okay. So I've had students in the past find this very useful. So like if there's a y and an x squared times a, where a is just not 0, right? That's a parabola. Okay. When it's just a y. And x squared is like the biggest power of x that you have. Okay. If you have a positive x squared and a positive y squared, That's a circle. Okay. But if you have a positive ax squared plus a by squared, right? Where at least one of a or y, or when at least one of a or b is not one, then that's an ellipse. Okay. Um, because if a equals b, then you just move that to the other side, and then that's your radius, and then it is a circle. Okay. It's like for a and b, not the same, and one of them is not one. Well, if they're both one, then they are the same, right? Um, and then hyperbola is you're going to have this x squared, this y squared stuff, but one of them is going to be negative and one of them is going to be positive. Okay. Not every hyperbola looks like that. Okay. But if it does look like that, then it is a hyperbola. All right. Sorry, I went over time. But I'll hang out here for a second in case anybody has any questions. But have a good day. Stay safe. Stay warm. Talk to you later.